This GPU is performing these things in very faster way because of the matrix operations only, right? So there's a reason that matrix is really important for us, and entire deep learning is based on the matrix only. Okay, so let's take how exactly the matrix is getting stored inside the memory. Remember guys, we already discussed that there is a two kinds of a representation. One will be a logical representation and another one will be a physical representation, right? So if you create a matrix, you won't find any matrix created inside the memory, right? Because memory is a collection of sequential location. So everything is getting stored in the sequential manner, right? So to store a matrix in a memory, we have a two ways. First one will be a right. There are the two ways to store the matrix inside the memory. First one will be a RMO, which is nothing but a row major order, and second one will be a column major order. See guys, most of the memory architectures, if you see the advanced memory architecture, is following the row major order, right? Why it is following, that is a different story guys. हम कोई architecture यहाँ पे discuss नहीं करेंगे, but I'm writing here like this: the modern memory stores a matrix data in row major order. I will discuss guys the architecture of the memory when we'll discuss the GPU, right? Whenever we'll discuss the NVIDIA GPU architecture, that how exactly the things are getting stored, correct? But in a modern memory, store the matrix data in a row major order. The one constraint here will be constraint here will be if we are storing a matrix in a row major order, matrix in a row major order, then access the elements also using row major order. Similarly for column major order. These are the constraint guys. If you are storing in the CMO column major order, then definitely you access in the column major order, right? Because यदि आप ऐसा ना करोगे, so it will be the inefficient way. It will be the inefficient way. Inefficient way because it leads to, or I can say that the number of page faults will increase. The number of page faults will increase guys. Okay, listen one thing guys, there is a different story related to the page faults. Okay, I'll explain you with the help of simple example. Okay, so usually what happen guys, let's take first understand how exactly the row major order will store and column major order will store. Okay, and then I will explain what is the page fault. Again, this concept will comes under the NumPy whenever we'll discuss about the spatial and temporal aspects of the NumPy, right? So let's take here, I'm talking here RMO, row major order. This is the matrix is given to you. So you stored a data in a row wise case, right? Like this. For example, this is the matrix given to you. You stored a data row by row like this. So I'm having a sequential location like this. I'm storing 1, 2, 3, 4, 5, 6, 7, 8, and 9 like this. So usually this will be a row, first row, second row, and this will be a third row like this. जैसे कि मान लीजिए in the memory it will be stored in the sequential location. मैं contiguous की बात इसलिए नहीं कर रहा हूं because we don't know whether the memory is there or not, right? So here I'm writing this one will be a row 0 because in a Python the index is starting from 0. So this will be a row 1 and this will be a row 2. correct? So here you are storing 1, 2, 3, then you are having a 4, 5, 6, then you are having a 7, 8 and 9. So if they have given a matrix, you store the matrix in this way. This is nothing but a row major order, correct? समझाया guys? Row major order means you are storing a data row wise, that's it. But whenever I'm talking about the column major order, whenever I'm talking about the column major order, CMO will be you stored a column wise data. So column wise means you say 1, 4, 7, correct? Then 2, 5, 8, and then you say 3, 6, 9, correct? You're storing the data column wise here. That is nothing but the column major order. So in this case, you will get like this. So this will be your column 0, this will be your column 1, and this will be your column 2. So you write here 1, 4, 7. You're getting here 2, 5, 8, right? And you're getting here 3, 6, 9. This is nothing but your column major order. You're storing a data in this, correct? Clear guys, how exactly the row major order and column major order are getting stored? Okay. Listen guys, now what will happen? See guys, try to explain you in very high level, right? I will not go too much deeper because it will go into the operating system, which is not required now, correct? So let's take, I'm giving a simple example. Usually guys, whenever you are storing a data, let's take, I wanted to store a matrix in memory. So usually where exactly it is getting stored permanently on your hard disk, correct? Hard disk is only a permanent storage. Now, whenever you are loading this data onto the memory, it is getting loaded in the form of pages, right? So I'm telling that whenever we are loading data onto the main memory, it is getting loaded in the form of pages. It is getting loaded in the form of pages. ठीक है, देखिए मैं सिंपल बता रहा हूं आपको कि इट इज गेटिंग लोडेड इन द फॉर्म ऑफ पेजेस, बट इन अ मेमोरी यू आर हैविंग अ फ्रेम्स. मैंने आपको बोला था मेमोरी इज अ कलेक्शन ऑफ फ्रेम. सो टू होल्ड दैट पेज वी आर हैविंग अ फ्रेम इन अ मेमोरी. जैसे एक फोटो है, टू होल्ड दैट फोटो यू हैव अ फोटो फ्रेम ना. Same like to hold that pages, you are having a frame here, right? Inside that frame, you are storing a page, correct? So what will happen? Let's take as you are having a 3 cross 3 matrix. No? So I'm telling that let's take, we will create a 3 pages. 3 pages. Correct. So let's take page 1. And let's take, I'm telling that each page size is 3. Though guys, I'm explaining in high level. Don't get in different way because there is so much detail. You are having a page number, a frame number. Again, it is getting divided into logical address, physical address, but it is not required again, right? So I'm telling that each page size is 3 here, right? Let's take now page 1 will take here 1, 2, 3. I'm going row major order. I'm considering that. Consider a row major order. Consider a row major order. Correct. Now, whenever you are storing this is the page 1. I'm telling that now page 2. Correct. Page 2 is what now? Next one. Let's take 4, 5, 6. Then you are having a P3. You are having a 7, 8, and 9. Sorry, guys. You are having a 7, 8, and 9. So this data is getting stored in the different pages here, correct? So once I'm telling that I wanted to access the element, you are storing, you are loading onto the main memory in the form of pages, correct? So वहां पे एक page table create रहता है, right? Okay. So that will be a different story, but you consider it will be a pages case, right? Now, what will happen now in this case? Let's take suppose we are accessing using CMO. My data is stored in a row major order, and I'm trying to access a particular data in a column wise. Correct? So problem kya hota hai guys? Let's take. We know that access a first element. First element will be one, right? So usually guys एक साथ सारे frame load नहीं होते memory में, because memory RAM is a limited memory guys, right? So you cannot load the entire data onto the RAM, right? यदि आप ऐसा करोगे तो it will leads to the different problem, right? That's why we are having a static binding, dynamic binding, this kind of a thing, right? We are using the concept of overlays to solve this problem, right? So access a first element, and the first element is one. Now guys, initially whenever I'm trying to access, it will load the page one onto the memory. Now I'm telling that you have wanted to access a element one, and page one is loaded onto the memory. Correct? Now you will access the one guys, not at all issue, because page one is onto the RAM now, and you can easily get the first element. Although I'm accessing column wise guys, but I can easily get the first element because column ka bhi first element one hi hai. Yes or no? So I can get, because one is present in page one, we can get it. Means there is no page fault. पेज फॉल्ट का मतलब ये होता है गाइस कि अगर आप किसी चीज को ढूंढ रहे हो और दैट थिंग्स इज नॉट अवेलेबल इन द मेमोरी, दैट लीड्स टू द पेज फॉल्ट. जैसे आपने कैश हिट कैश मिस सुना होगा, राइट? इट इज हैपनिंग इन द डिफरेंट लेवल, है ना? बट हियर आई एम टॉकिंग इन द सेंस ऑफ मेन मेमोरी. जब भी मैं मेन मेमोरी और सेकेंडरी स्टोरेज का बात करूं, आई एम टॉकिंग अबाउट द ऑपरेटिंग सिस्टम. एंड व्हेनेवर आई एम टॉकिंग अबाउट द कैश मेमोरी, डी रैम, usually I'm talking about the architectural point of view, right? So here I'm keeping very simple as a programmer's aspect, that how exactly the things are getting done. Now guys, next thing, I wanted to access a next element, access the second element. What is the second element? Is 4 na guys. Now 4 is not present in the page 1. Correct? I am telling that 4 is not present in the page 1. If it is not present in the page 1, you will get guys page fault. This is the problem. If you are storing a data in a row major order, that's why they have given the constraint. If you are storing a data in a row major order, better to access in the row major order only. Don't access in the column major order, right? And if you are storing a data in a column major order, try to access in the row major order, right? But this is very low level guys, है ना? इसके बहुत सारे solutions है, right? How exactly the things are getting access, right? So there are having a temporal aspect, spatial aspect की आपका page fault कम हो, right? Because to solve this particular problem, you are having a mini solution for this one. But this is the thing that whenever